In this video, I'll be viewing the extra buoyancy problem that was given in class to some people and was also posted on Blackboard or on Drive for you to try on your own. So to get started on this, we have information about this chromium block, and we want its mass for our first question. Because we are given the weight here, we can use the formula that relates weight and mass, so we can either think of it in the form W equals m times g, where this is weight equals mass times gravitational acceleration, or we can rearrange this to the form weight over gravitational acceleration equals mass. This one is going to be the one that is more suitable for our form, and so as we go through this and plug in our weight, which is 600 newtons, and our gravitational acceleration, which is the 9.8 meters per second squared value that we use frequently, this should equal our mass, and we'll end up with about 61.2 kilograms as our mass for this. So that'll take care of our first part of the problem, and from there we can go on to the second. In the second part of the question, we are asked for the volume of the chromium block. So to figure out the volume here, we're going to have to think about what formulas could be relevant to this and think how to apply them here. In order to do so, we can consider that volume comes up in the density equation, and we can solve that for volume, and that looks like volume equals mass over density. So this is a way that we can solve for volume using the mass and the density if we have them. We'd want to think, does that make sense here? We do have the mass. The density was given in the early part of the problem where it said it was 7.19 grams per milliliter. So we really have all the information that we need for this. One thing that is important to consider, though, is the fact that the density, as I mentioned, is in the units grams per milliliter. This suggests that we need to have mass in grams in order for this to work out in terms of the units. We need the grams to cancel with each other to end up with a volume unit for our answer. Because we have our previous mass in kilograms, 60.2 kilograms, we're going to need to convert this to regular grams so that we can use it with our density from before. We can do this by setting up a conversion with dimensional analysis. We're going to multiply the conversion factor with kilograms on the bottom, grams on the top, and appropriate values will be 1,000 grams with 1 kilogram. Let's look on to 61,200 grams as our mass for the block in grams. We can now go ahead and plug this into our equation. So I'll have that 61,200 grams on top, our density, which was 7.19 grams per milliliter on the bottom. Our units are all set up, so that's good for us. And we will just need to do the calculation at this point, which ends up giving us about 8,500 milliliters. We're not going to be too concerned about the significant figures here, so I'll just write this out to the units place and round it there. And so we end up with a 12 for our volume in milliliters. This is through the first two parts of the question where we were just dealing with the chromium block on its own. From this point, we would need to go on to the next part to deal with the ethanol, and I will go over that in future videos.